Hello everyone, in this recording we're going to talk about how you can read in data using D3. So it's not entirely obvious how you should do this, right? There is a function called d3.csv, and you would think it works like R's read.csv, but it works a little bit differently. So let's just think if it were exactly analogous to R, you should be able to use something like this, right? And I'm just copying it into a blank HTML page where I've loaded D3. If I try just running this, so CSV or Gapminder is in this directory. But if I just look at data, it doesn't actually return the data set, right? It returns something called a promise. So, okay, here it actually does have the results. Hello everyone, in this recording we're going to talk about how you can read in data using D3. So the process is a little bit different than in using R. So there is a function called d3.csv, and you would think it runs like read.csv in R, but there's some subtle differences. So in this example, I have a CSV file called gapminder.csv, and I've put it in the same directory as where I'm doing all my D3 coding. And you would think that this is going to store, it's going to read in all the rows of the CSV file and it's going to store it in this data object. But it doesn't quite work this way. I'll show in an example. Here is a blank HTML page. I can even show, just blank HTML. The only thing I've done, I've loaded in some JavaScript, or the D3. Load data 0, actually I've commented everything out. So this is just the D3.js. Right. If I call data, it runs, but if I try to look at what data is, it's actually a promise. So a promise is not just a data frame. It's not just a kind of clear object, right? So we're going to need a way to actually convert it into an array, something that we can work with, right? So the way you can access a promise is by using this then command. The issue is that D3 is built for reactive environments. So it's not really assuming that the code is going to be running line by line. It might be the case that some data elements only become available after the web page has already loaded. So for this reason, it's more common, you usually have to write it this way. So what then is doing is saying, first try to fetch this Gapminder dataset. Once you've succeeded in fetching it, then run whatever command I put here. Right. So here, the function, all it does is it logs the dataset. But now, so it ran the promise, but now it's actually showing me an array of objects. And each of these objects is one country from the Gapminder dataset. Right? So this is what you can actually start using to build your D3 visualizations, just like all the circles and scatter plots that we've been making so far. Okay. So that's one key point. Now, I hid one important detail, is you can't just open a kind of standard HTML file. So what I'm showing here, this is actually a server. I've started up a server in the background. I can go to the same directory if I didn't have a server. So, and then load. Okay, if I tried doing the exact same thing, so exact same thing without the server running, it's giving me this kind of strange error, right? Some sort of course policy block. What's going on is that it's trying to save the JavaScript from just automatically downloading some CSV file. Right? This can be very dangerous if it's an untrusted website, right? So we need to create some sort of actual server so that it realizes that this is a safe page that we can download data from. So the way you can do this is to start an HTTP server using Python. now instead of just going to the raw full path, I can give it this localhost, and this was the file that I had been in. And now this is everything that I'd shown before was on this version. Okay, so it's an important point. If you're trying to do any kind of data loading, you're probably going to want to start a server first. Okay, so now final point. So the data looked fine when we loaded it. We can look again here. But there's an issue, right? Like, it thinks that LPOP is a string. It thinks that population is a string. It thinks that life expectancy even is a string. So we're going to need to convert these to numbers if we're going to do anything interesting with them. So how can we parse them? There's a handy function D3 called autotype. What this will do, it will try to infer the types of each of the objects. So you can pass this in as the second argument for d3.csv. So I'm just going to run this version. Right, and now we see all the numbers are actually properly parsed. If you want to do some of your own parsing, you can actually pass in your own parsing function here. But that would be only if you have like a very specific kind of date format or some very specific kind of data structure. Okay, so that was it. Remember to use .then so that you can access the actual data set rather than just the promise to the data set, and start the background server. We can make a little visualization now that we've loaded the data. So what I'm going to do here, I'm going to plot log population against life expectancy just for one of the years. So here I'm filtering the data to be just 1965. I think it's the very first year in the data set. And then I'm going to use the usual data bind, enter, exit, update pattern so that I can show circles associated with each of these data points. Right. So this just binds data. I'm entering, so I'm noticing that there are a lot more data points than there are circles in my current selection, and I'm going to append a circle for each of the missing tags. And then I'm going to encode the locations. So I'm using LPOP to figure out the x coordinate, and I'm using life expectancy for the y coordinate. I'm using this 10 times because otherwise, LPOP would be very compressed on the page, and I want to spread it out across more pixels. We're going to see a more proper way to do that using scales in a future lecture. Okay. This is the code that generates the scatter plot that appends all the circles, and I'm going to put them all into this visualize function. So once it loads the data, it's going to run this visualize. And here we go. A tiny scatter plot. It's not nearly as impressive as some of the cool animations we had before, but it is based on real data. So this is going to be the starting point for all our more sophisticated data visualizations.